Today we are going to pull together everything we know about solving equations and solve some trig equations. Find all solutions of each equation for the given interval. We're going to solve 4 times cosine squared theta equals 1 for the interval of 0 to 360. The first thing you want to do is to try to isolate your trig function. So we're going to isolate cosine theta. That means solve for cosine theta. The opposite of 4 times is divide by 4, both sides of your equation. That gives us cosine squared theta equals 1/4. To undo squared, you take the square root of both sides of your equation. So we have cosine theta equals positive or negative because we're taking the square root of 1. Square root of 1 is 1 over 2. The square root of 4 is 2. Now you go to your unit circle and you want to find all angles in degrees where the cosine value is 1/2. On your unit circle, you have x and y coordinates. The cosine is your x coordinate. So you're going to look at all of your x coordinates and pick all the angles where cosine is positive 1/2 or negative 1/2. So continue to go around the unit circle and look for cosine values that are positive 1/2 or negative 1/2. So the solutions for theta would be 60 degrees, 120 degrees, 240 degrees, and 300 degrees. Alright, again, we want to isolate the sine theta. So we're going to solve the equation for sine theta by first adding radical 3 to both sides of the equation. To continue to solve for sine theta, we're going to divide by 2. So we have sine theta equals radical 3 over 2. So at this time, you go to your unit circle and you want to find all angles in radians this time where the sine value is radical 3 over 2. So you go over to your unit circle. We're looking at the y values for sine, and we're looking for radical 3 over 2 here at pi over 3, and radical 3 over 2 here at 2 pi over 3. This is negative 3 pi over 2, so that does not apply, and this does not apply because we're looking for positive radical 3 over 2. So pi over 3 and 2 pi over 3 would be the solutions. Number 3. First thing we're going to do is try to get everything on the same side of the equation, because if you can see, we have a cosine squared and we have a cosine. Just like quadratic equations, when you have an x squared and an x, you end up factoring. So once you subtract the 1 from both sides, here's what you have. And we will factor here using the slide and divide method. So that method, I'm going to rewrite the problem, and I'm going to replace my thetas with x. You slide your 2 to the end of your equation and multiply it against the 1. So you have cosine squared x plus cosine x minus 2. Now you would do the x method. In the top of your x, you place negative 2. In the bottom of your x, you place the number in front of the cosine, which is positive 1. So you're looking for two numbers to multiply to give you negative 2 and add to give you 1. Of course, that's 1 times 2, but you have to get your signs right. To end up with a positive 1, you need a negative on your 1 and a positive 2. So it factors into cosine x minus 1 and cosine x minus 2. But this is slide and divide, so now we must go back and divide by the number that you slid in the beginning. You slid the 2. So you divide these two numbers by 2. 1 doesn't divide into 2 evenly, so you take that 2 and you put it in front of the cosine. So you have 2 cosine x minus 1 times cosine x minus 1, because 2 divided by 2 does divide evenly. And it's equal to 0. You take each factored term, set it equal to 0, and solve for cosine x. So we have cosine x equals, once you move the 1 over and divide by 2, 1/2. And cosine x equals, move the 1 over, positive 1. So this time we're looking at the unit circle and we're looking for all locations in radians where cosine equals 1/2 or 1. So those locations, if you go around your unit circle, should be pi over 3, pi, and 5 pi over 3. Let's move down to number 5, because you also factor on number 5. Notice on number 5, we don't have the same two trig functions. When you don't have the same two trig functions, you want to change one of the functions in terms of the other. So if you look on your trig cheat sheet, you will see that cosine 2 theta can be changed to 1 minus 2 sine squared x. That is under the double angle identities. Now notice I have a sine squared and a regular sine. So that tells me I need to get everything on the same side of the equation, because it's a possibility that I will be factoring. Since I have a negative 2 sign, I'm going to move everything to the right this time. So I have positive 2 sine squared x. I'm moving the 1 over, so it becomes a negative 1. But I'm going to put my sign first. Now, again, you factor here using slide and divide. So it becomes 2 sine x minus 1 and sine x plus 1. You set each factor term equal to 0 and solve for x. So we have sine x equals positive 1/2 and sine x equals negative 1. At this time, go to your unit circle and look for all locations in degrees where x, the sign of it, x equals 1/2 or negative 1. And those locations are 30 degrees, 150 degrees, and 270 degrees. Number 6, we will also factor. But notice first, we have a sine squared and we have a cosine. So I am going to change sine squared using a Pythagorean identity. I'm going to change sine squared to 1 minus cosine squared x. I want to get everything on the same side of the equation. So once I start moving everything to the left side, I have positive cosine squared x minus 3 cosine x. And when you try to move your ones, you will see that they cancel on both sides. So I don't have 3 terms here, but I do see that I can factor out a GCF. The GCF will be cosine x. Factor out my cosine x, I have cosine x minus 3 left. Set each factored term equal to 0 and solve for x. So I have cosine x equals 0 and cosine x equals positive 3. So you go around the unit circle and we're looking for all locations where cosine equals 0, because we should know that cosine doesn't equal 3 anywhere because the radius of a unit circle is 1. So cosine x equals 0 at in degrees, 90 degrees, and 270 degrees. And number 4, we're going to solve the equation for secant. So we have secant theta equals 2. The unit circle has sine and cosine values. So what do we know about secant? We know that secant is the inverse of cosine. So secant theta equals 1 over cosine. So if secant theta equals 2, the inverse of it would be for cosine theta would have to equal 1 over 2. So we're looking around a unit circle and we're looking for all angles in radians where cosine equals 1/2. And that is pi over 3 and 5.